Good morning, everyone. I hope all of you are doing well today. Welcome back to another session of the Wipro Talent Next program on data science using Python. I hope everyone has their laptop ready and Python installed because today we are going to learn two very useful Python concepts that every Python programmer and data scientist should know. These concepts are Lambda functions and list comprehension. These two features help us write programs that are shorter, cleaner, and easier to understand. In data science, we often work with thousands or even millions of records. When our code is simple and efficient, it becomes easier to maintain and execute. That is why these concepts are very important. Before we begin writing programs, let's understand what we are going to learn in today's lecture. By the end of today's session, you should be able to understand what a Lambda function is, when we use it, how it works with the map function, and how list comprehension helps us write Python programs in a much shorter way. Later in the lecture, we will also compare list comprehension with the traditional for loop and solve several practical programming problems together. Now, before I explain Lambda's simple question, suppose I ask you to write a program that adds two numbers. Immediately, most of you will think about writing a function using the def keyword, something like this. There is absolutely nothing wrong with this approach. But imagine that you need this function only once in your entire program. Would you still create a complete function with a name? Probably not. Python gives us another option called a Lambda function. A Lambda function is simply a small function without a name. Because it has no name, we also call it an anonymous function. It is generally written in a single line and is useful when the operation is very small. Think about a calculator. When you press the square button, the calculator immediately squares the number and gives the answer. It doesn't save that operation permanently. It simply performs the task and finishes. A Lambda function behaves in a similar way. It performs one small task and immediately returns the result. Now, don't worry about remembering the definition. Definitions are easy to forget. Instead, let's understand Lambda functions by writing a real program. Please open your Python editor. I will type the program slowly. You should also type the same code on your computer. Our first task is very simple. We have a list containing numbers from 1 to 9. We want to find the cube of every number. Instead of writing a normal function, we will solve this problem using a Lambda function together with Python's map function. Now let's start typing. You can see the code. Don't panic after seeing this line. Many students think this is a difficult statement. Actually, it is made up of 3 simple parts. Let's understand each part one by one. The first part is map. Can anyone tell me what the word map means in English? Yes. It means to apply something everywhere. That is exactly what Python does. The map function takes every element from the list one by one. It sends each element to another function. In our program, that other function is the Lambda function. Now look carefully at this part. This is the Lambda function. The keyword Lambda tells Python that we are creating an anonymous function. The variable x represents one element from the list. Initially, x becomes 1. Then Python calculates 1 cube. Next, x becomes 2. Python calculates 2 cube. Then x becomes 3. Python calculates 3 cube. This process continues automatically until the last element of the list. So let us imagine what happens internally. Python takes the first number, 1 becomes 1 cube. Next it takes 2, 2 becomes 8. Then 3 becomes 27. Then 4 becomes 64. The same process repeats until 9 becomes 729. After processing every value, map returns all the answers. But there's one small problem. The map function does not return a normal list. It returns a special object called a map object. If we directly print it, we will not get the list we expect. Therefore, we use the list function to convert the map object into a proper Python list. Finally, the complete list is stored inside the variable cubed list. Now, before running the program, I want everyone to think for a few seconds. Can anyone tell me what will be the cube of 5? Yes, 125. What about the cube of 7? 343. Very good. So based on our understanding, can you predict the complete output? It should contain the cubes of all numbers from 1 to 9. Now let's execute the program. You can see the code in our conversation history. Observe the output carefully. You can see the code in our conversation history, exactly the same result that we predicted. This is always a good programming habit. First, predict the output, then execute the program. If the output matches your prediction, it means you have understood the logic correctly. Now let me ask you one more question. Can we write this program using a normal function instead of a lambda function? Yes, definitely. But it would require more lines of code. The advantage of lambda functions is that they allow us to write small operations in a single line. This makes the program shorter and easier to read when the logic is simple. However, remember one important point. Lambda functions are not a replacement for normal functions. If your logic is large or contains many statements, always use the def keyword. Use lambda functions only for short and simple operations. So let's quickly revise what we learned in this section. Today we understood that a lambda function is an anonymous function, meaning it has no name. We learned that it is useful for short, one-line operations and is commonly used with functions like map. We also saw how map applies the lambda function to every element in a list, and how list converts the result into a regular Python list. Finally, we executed our program and verified that the output contained the cubes of all numbers from 1 to 9. List comprehension and comparison with for loop. In the previous section, we learned about lambda functions and saw how they help us write small functions in a single line. We also learned how the map function works together with a lambda function to process every element of a list. Now let us move to the second important topic of today's lecture, list comprehension. I want to begin this topic with a simple question. Suppose I ask you to create a list containing the square of numbers from 1 to 10. What will be your first thought? Most of you will probably say, "Sir, we will use a for loop." Absolutely correct. A for loop is one of the most common ways to create a new list in Python. But Python provides another feature that helps us perform the same task with fewer lines of code. This feature is called list comprehension. The name itself tells us something. We are creating or generating a list in a smarter and more compact way. List comprehension is one of the most loved features of Python because it makes programs shorter, easier to read, and often faster to execute. Whenever data scientists need to create a new list from an existing collection, they frequently use list comprehension instead of writing multiple lines of code. Let us first understand the basic syntax. The general syntax of list comprehension is, you can see the code in our conversation history. Don't try to memorize this syntax. Instead, us understand it naturally. Read it from left to right. First, we decide what output we want. Then we tell Python which elements to read. Finally, Python automatically creates the new list. Think of it as a factory. Raw material enters from one side, processing happens inside, finished products come out from the other side. Similarly, the input list goes into list comprehension, Python processes every element, and finally produces a new list. Now let us understand this using a practical example. Our task is to print all perfect square numbers that are less than or equal to 50. Before writing list comprehension, let us first solve this problem using a normal for loop. This will help us compare both approaches. Please type the following PNG 150 if int I 0.5 equals I.5, print I. You can see the code in our conversation history. Here, range 150 generates numbers starting from 1 up to 49. Python stores one number at a time inside the variable I. Initially, I becomes 1, then it becomes 2, then 3, then 4. This process continues until 49. Now look at the next line. You can see the code in our conversation history. Many students become confused here. Let's simplify it. First, I is raised to the power of 0.5. Do you know what power 0.5 means? Exactly, it means the square root. So when I is 16, Python calculates the square root. The square root of 16 is 4. Now Python converts it into an integer. Since both values are exactly equal, Python knows that 16 is a perfect square. Now imagine I becomes 18. The square root of 18 is approximately 4.24. After converting to an integer, it becomes only 4. Now compare them. 4 is not equal to 4.24. Therefore, Python understands that 18 is not a perfect square. Only when the condition becomes true does Python execute the next statement. You can see the code in our conversation history. This prints the perfect square number. Now, before running the program, let us predict the output. Can anyone tell me the perfect square numbers below 50? Very good. 1, 4, 9, 16, 25, 36, 49. Let's execute the program. Observe the output carefully. You can see the code in our conversation history, exactly the output we expected. Now let me ask another question. How many lines of code can we reduce this? The answer is yes. That is exactly where list comprehension helps us. Now look at the list comprehension version. You can see the code in our conversation history. At first glance, this line may look difficult, but actually it contains the same logic as the for loop. Let us read it slowly. The first part is, you can see the code in our conversation history. This tells Python what we want to do. The second part is, you can see the code in our conversation history. This tells Python where the data is coming from. The last part is, you can see the code in our conversation history. This filters only the perfect square numbers. Notice something interesting. The logic has not changed. Only the way of writing has changed. The output will still be exactly the same. Let's execute the program. Again, we obtain. You can see the code in our conversation history. So both programs solve the same problem. The difference is only in the number of lines written. This is why professional Python programmers prefer list comprehension whenever the logic is simple. Now I want all of you to think about one question. If the logic becomes extremely cosy ourselves to use list comprehension? The answer is no. Readability is always more important than writing fewer lines. If a normal for loop makes the program easier to understand, then use the for loop. Programming is not about writing the shortest code. Programming is about writing code that everyone can understand. Now let us move to another interesting example. Until now, we have used list comprehension with numbers. Can we use it with strings? Yes, absolutely. Remember one important rule. A string is also an iterable object. Python reads one character at a time. Therefore, we can apply list comprehension directly to a string. Please type the following program. You can see the code in our conversation history. Let us understand it. Python starts reading the string. The first character is W. It stores it inside the variable letter. Then it reads I, then P, then R, finally O. Each character is added to a new list automatically. Now before running the program, tell me what should be the output. Exactly. A list containing individual characters. Let's execute it. The output becomes very simple. Without writing any loop ourselves, Python has converted the string into a list of characters. This is another beautiful application of list comprehension. So let us stop here for a quick recap. Today we learned what list comprehension is and why Python programmers par only for loop with a list comprehension solution, and observed that both produce the same output, but list comprehension requires fewer lines of code. We also learned that list comprehension works not only with numbers but also with strings because strings are iterable objects. Finally, we converted the word Wipro into a list of individual characters using a single line of Python code. Excellent work, everyone. In the next section, we will explore conditional list comprehension, nested if conditions, dictionary comprehension, and solve practical programming tasks exactly as demonstrated in the uploaded lecture material. Conditional list comprehension, nested conditions, and dictionary comprehension. Welcome back, everyone. So far, we have learned two important concepts. First, we learned how Lambda functions help us write small anonymous functions. Then we learned how list comprehension allows us to create lists in a much shorter and cleaner way compared to traditional for loops. Now I have a question for all of you. Suppose I ask you to create a list containing only even numbers from 0 to 19. Can we still use list comprehension? Yes, absolutely. In fact, this is one of the most common applications of list comprehension. We don't always want every element from the original list. Sometimes we only need elements that satisfy a particular condition. Python allows us to add an if condition directly inside list comprehension. This makes our programs very compact and easy to understand. M. Please type the following code exactly as I type it. Let's understand this line carefully. First, look at the variable number list. This variable will store our final answer. Now move to the right-hand side. We start with x. This is the value that we want to place inside the new list. Next comes the for statement. Python starts generating numbers from 0 to 19. One number is taken at a time. Initially, x becomes 0, then 1, then 2, then 3. This process continues until 19. Now comes the most important part. Can anyone tell me what this condition checks? Exactly. It checks whether the number is divisible by 2. The modulus operator cent returns the remainder after division. If the remainder is 0, the number is even. If the remainder is 1, the number is odd. So, what happens internally? Python checks every number one by one. When x is 0, the condition is true, so 0 is added to the list. When x becomes 1, the condition becomes false, so Python ignores it. When x becomes 2, the condition is true again. 2 is added. The same process continues for every value. Before running the program, let us predict the output. Will 1 appear in the list? No. Will 2 appear? Yes. What about 7? No. What about 18? Yes. Excellent. Let's execute the program. The output is Suppose I ask you to create a list containing numbers that satisfy 2 conditions. The number should be divisible by 2. At the same time, it should also be divisible by 5. Can we do this using list comprehension? Yes. Python allows us to write multiple if conditions one after another. This behaves exactly like an AND operation. Every condition must be true before the element is selected. Please type the following program. Now, let us understand this program carefully. Python starts generating numbers from 0 to 99. Each number is stored inside the variable y. Now, Python checks the first condition. You can see the code in our conversation history. Only even numbers pass this condition. Next, Python checks another condition. You can see the code in our conversation history. Now the number must also be divisible by 5. Only when both conditions become true does Python include that number in the new list. Let's understand with an example. Suppose y is 20. 20 is divisible by 2. The first condition becomes true. 20 is also divisible by 5. The second condition also becomes true. Therefore, 20 is added to the list. Now consider 30. 30 satisfies both conditions. It is added. Now think about 22. It is divisible by 2, but it is not divisible by 5. Therefore, Python ignores it. Now think about 25. It is divisible by 5, but not divisible by 2. Again, Python ignores it. Only numbers satisfying both conditions appear in the final output. Before executing the program, can one predict the first few values? Very good. 0, 10, 20, 30, 40. Let's execute the program. The output becomes exactly correct. This example shows that multiple if conditions can easily be used inside list comprehension to perform advanced filtering without writing complicated loops. Now let us move to another exciting concept called dictionary comprehension, lists. But can we create dictionaries automatically? The answer is yes. Just like list comprehension creates lists, dictionary comprehension creates dictionaries. Remember that a dictionary stores data as key value pairs. For example, student name marks country, capital employee ID, employee name, product ID, price. Whenever we need to generate these mappings automatically, dictionary comprehension becomes extremely useful. Let's understand this using a practical example. Please type the following program. Now let us understand the logic. First, we have 2 separate lists. The first list contains country names. The second list contains capital cities. Our objective is to combine both lists into one dictionary. Inside the function, Python starts generating index values. Initially, I becomes 0. The key becomes India. The corresponding value becomes New Delhi. Python creates the first key value pair. Next, I becomes 1. The key becomes Nepal. The value becomes Kathmandu. Python creates the second pair. Finally, Bangladesh becomes the key. Dhaka becomes the value. Python combines everything into one dictionary. Before executing the program, can anyone predict the output? Exactly, the output should be Eshfried. You can see the code in our conversation history. Now let's execute the program. Observe the output carefully. Everything has been combined automatically into a dictionary. This is much easier than manually inserting every key value pair one by one. Now let us stop for a quick revision. Today we learned that list comprehension can include if conditions to filter only the required element E if conditions can be written together, which work like an AND condition. Finally, We introduced dictionary comprehension, where Python creates dictionaries dynamically using key value pairs, making programs shorter, cleaner, and easier to maintain. Excellent work, everyone. You are now comfortable with Lambda functions, list comprehension, conditional filtering, nested conditions, and dictionary comprehension. In the final part of this lecture, we will solve the practical tasks from the uploaded material, including creating a dictionary of odd numbers and their cubes, generating an alphabet dictionary, discussing real-world applications, common interview questions, and concluding the session with a complete summary. Final topic: hands-on practical tasks, real-world applications, interview tips, and lecture conclusion. Welcome back, everyone. So far, we have covered almost everything about Lambda functions and list comprehension. We started with the basic concepts, understood how Lambda functions work with the map function, compared list comprehension with traditional for loops, and finally learned how to use conditional filtering and dictionary comprehension. Now it is time to apply everything we have learned. Remember one important thing: programming is not a theoretical subject. You don't become a programmer by reading notes. You become a programmer by writing programs, making mistakes, debugging them, and finally getting the correct output. So in this final section, we will solve two practical programming tasks together, exactly like we would do in a coding interview or a laboratory session. These examples are taken from today's module and will help you understand how list comprehension is used in real programming problems. There are 8, a dictionary of odd numbers and their cubes. Let's read the problem carefully. We have a list containing the numbers 1, 2, 3, 4, 5, 6, and 7. Our task is to create a dictionary that contains only odd numbers as the keys and the cube of each odd number as its value. Before writing any code, let us think logically. Which numbers are odd? 1, 3, 5, 7. These 4 numbers should become the keys of our dictionary. Now what should be their corresponding values? 1 cube is 1, 3 cube is 27, 5 cube is 125, 7 cube is 343. So, before executing the program, we already know what our final dictionary should look like. This is an excellent programming habit. Always think about the output before writing the code. Now let's write the program. You can see the code in our conversation history. Now let us understand the program line by line. The first line creates a list containing 7 numbers. Nothing new here. Now look carefully at the second line because this is where the entire logic is written. We begin with curly brackets. Whenever you see curly brackets with key value pairs, immediately remember that Python is creating a dictionary. Inside the brackets, we write x cubed. This means the number itself becomes the key. Its cube becomes the value. Next comes the for statement. Python starts reading each number one by one from the list. Initially, x becomes 1, then 2, then 3, then 4. This process continues until 7. Now observe the last condition. You can see the code in our conversation history. This condition selects only odd numbers. When x becomes 1, 1 divided by 2 leaves remainder 1. Therefore, 1 is selected. When x becomes 2, the remainder becomes 0. Python ignores it. When x becomes 3, the condition becomes true again. Python creates another key value pair. The same process continues until the last element. Now, before executing the program, tell me once again what output you expect. Exactly. 1 maps to 1, 3 maps to 27, 5 maps to 125, 7 maps to 343. Let's execute the program. The output becomes exactly as expected. This single line has replaced many lines of traditional for loop code. Practical task 2. Another interesting problem. This time, our objective is to create a dictionary containing all 26 English alphabets. Each alphabet should be mapped to its corresponding position. For example, A should map to 1, B should map to 2, C should map to 3, and so on until Z maps to 26. Now think for a moment. Can we manually type 26 key value pairs? Of course we can. But imagine doing that every day. It would be time-consuming. Python provides a much better solution. Let's write the program. You can see the code in our conversation history. Let's understand every part carefully. The first line imports the string module. This module already contains many useful predefined values. One of them is ASCII lowercase, which stores all lowercase English letters from A to Z. Now comes another useful Python function called enumerate. Can anyone tell me what enumerate does? Suppose I have a list of students. Instead of giving me only the student names, enumerate also gives me their position numbers. Exactly the same thing happens here. Initially, index becomes 0, 0, letter becomes A. Since we want numbering from 1 instead of 0, we simply write index plus 1. Now Python creates A becomes 1. Next, index becomes 1, letter becomes B. Python creates B becomes 2. This process continues automatically until Z becomes 26. Now, before executing the program, can anyone tell me what will be the value of letter M? Correct, 13. What about letter Z? 26. Excellent. Let's execute the program. Like Python displays the complete alphabet dictionary. Notice that we generated 26 key value pairs automatically using only one statement. Imagine how many lines we would have written without dictionary comprehension. This example shows why Python is one of the most popular programming languages in data science and automation. Real-world applications. Now, many students ask me on, do we actually use Lambda functions and list comprehension? That is a very good question. Let me give you some practical examples. Suppose you are working in a company like Wipro, TCS, Infosys, or Accenture. You receive a data set containing 1 lakh employee records. You need to extract only employees whose salary is greater than 50,000. Instead of writing a long for loop, you can use list comprehension. Suppose you are working on an e-commerce website. You need to calculate discounted prices for every product. A Lambda function together with map can perform this calculation very efficiently. In data science, we often clean datasets before building machine learning models. Sometimes we need only positive values, sometimes only even numbers, sometimes records belonging to a particular city. List comprehension makes these filtering operations very simple. Similarly, dictionary comprehension is useful when creating lookup tables, student databases, country capital mappings, employee ID records, or product price dictionaries. These concepts are used almost every day by Python developers. Common mistakes students make. Before we conclude today's lecture, let me share a few mistakes that beginners usually make. The first mistake is forgetting the order in list comprehension. Many students write the for loop first. Always remember the order: expression, then for, then if. The second mistake is forgetting that map returns a map object. If you need a list, always convert it using list. The third mistake is trying to write very complicated logic inside a Lambda function. Remember, Lambda functions are meant for small, one-line operations. If your function requires multiple statements, always use the def keyword. The fourth mistake is forgetting that dictionary comprehension requires both a key and a value separated by a colon. Avoid these mistakes, and your programs will become much easier to write and debug. Quick interview questions. Before I end today's session, let me ask you a few questions. Think about the answers. Question 1. What is a Lambda function? Question 2. Why do we use map together with Lambda functions? Question 3. What is the biggest advantage of list comprehension over a traditional for loop? Question 4. Can list comprehension work with strings? Question 5. What is dictionary comprehension? If you can answer all these questions confidently, then you have understood today's lecture very well. Assignment for students. Before our next session, I want everyone to complete the following practice exercises. Write a list comprehension program to generate the squares of numbers from 1 to 20. Create a list containing only prime numbers between 1 and 100. Write a dictionary comprehension program that stores numbers as keys and their squares as values. Use a Lambda function with filter to display only odd numbers from a given list. Finally, write one program using map, filter, and Lambda functions together. Practice these programs without looking at today's notes. That is the best way to improve your programming skills. Excellent work today, everyone. Today, we learned 4 important concepts. First, we understood Lambda functions, which are anonymous, single-line functions used for simple operations. Second, we learned list comprehension, a concise way to create new lists from existing iterables. Third, we compared list comprehension with traditional for loops and observed that it produces cleaner and more readable code. Finally, we explored dictionary comprehension, which allows us to create dictionaries dynamically using key value pairs. We reinforce these concepts through practical tasks such as generating odd number cube dictionaries and alphabet mappings. I encourage all of you to practice today's programs on your own systems. Try changing the INs and experiment with different data sets. The more you practice, the more confident you will become in Python programming. Thank you, everyone, for your active participation throughout today's session. If you have any questions, feel free to ask now. Otherwise, please save your programs, upload your assignments before the deadline, and be ready for our next class, where we will continue exploring more powerful Python features used in data science. Have a wonderful day and happy coding.